All right, I want to look at a for loop, and a for loop is probably one of my more favorite structures. I do a lot of mathematical computation, and for loops map out to summation notation that we use within mathematics. So what I'm going to do here is I want to create a new class. Now you won't be able to see this here, but I'm just going to do a summation. I'm going to name this, and you'll see that when I see my class. And what I'm going to use this for is an example of a sum of a for loop. So I'm going to add all of the numbers between 1 and 100. So let me go back here, and I'll go to Krita. Let me clear this out here. I'm going to try to slowly improve my handwriting on this particular tablet. We will get there. That's why I try to speak clearly when I'm writing, so these things turn into the same thing. All right, so if I want to add the numbers 1 through 10, you get 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Now, if you take discrete mathematics, which some of the CS majors need to here, Gauss found out that 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is 11, 4 plus 7 is 11, and 5 plus 6 is 11. And so you have 11 for half as many things. And so we have a formula that n times n plus 1 divided by 2 is the answer. But what we're going to do is we're going to let the computer do this calculation for us. So and in mathematical notation, we say that the sum is from our lowest number 1 to our highest number 10. And we're going to add. And what this does in mathematics is it says you start at 1, and then you'll add to it. Well, you increase this by 1, and since this is a sum, I'll put a plus 2, and then I add to this plus 3. And so I work my way through for each term until I get up to 10. And so this is something that we can integrate into our computer programming. So let's come back here, and we'll look at our sum. So I'm going to need an integer that is my sum. And I'm going to set it equal to 0 because when the program starts, it's 0. And I'm going to add the numbers from 1 to 10. So I'm going to use a for loop. Now I'm going to set my integer equal to 1 for my lowest number. And I'm going to continue for as long as I is less than or equal to 10. I want equality in this because I need the number 10. And I is going to increase by 1s. So I plus plus. So this sets I equal to 1. I'm going to keep going as long as I is less than or equal to 10. And then I'm going to increase I by 1. So what I need to do is sum plus equal I. So I'm going to take the value of sum and I'm going to put it into I. And so when I'm done, I'll print out, I'll use a printf here, the sum of 1 to 10 is %d because it's an integer. And I'll show off my sum here. Now Gauss's rule says this should be 55, but let's see what happens. And the sum of 1 to 10 is 55. And if I get playful here, I could make an integer for my higher number, my max. And let's say I wanted to do the sum from 1 to 100. I'll just have this compared to max. And I'll run this. And the sum, oops. Let me fix my output here. We'll go from 1 to max. Now that should be better output. Yep, the sum of 1 to 100 is 50-50. And so for loops are really, really nice when we're counting. And there are loads of things we need to count. We can count our way through lists of characters in a string. We can count our way through arrays, which are constructs we'll make in Chapter 7. But in general, for loops work really, really well with counting in different steps. As long as we have some condition here that we update, that will change this conditional.